Hi, and welcome to the 2016 Leaving Cert Ordinary Level Question 2 from Paper 2. If you want this video and access to the playlist, just subscribe to the channel. And if you want the notes I'm working off, just send me an email at shanetroy@gmail.com. The email address should be in the description below. So first things first, this question 2 here is a trigonometry question, which for a lot of people are challenging. But in past level, we're looking at using just a few formulas, and they're all available in the maths tables. So question 2 part A here is saying find the area of the given triangle. Now if you look at the triangle first, and this would be literally my first step, would be, is this right angled or not? Now hopefully it's fairly obvious that it's not right angled, and that kind of decides for you what formula you're going to use. Okay. The second thing is, what specifically does it ask you to find? And that's the area. Okay. So the formulas you might want to use are I hope I get this right, x1 times y2 minus x2 times y1, although to be honest, I checked that. Now that's one you would use in coordinate geometry. The big thing about that formula is that one of the points must be at 0, 0, on the vertices of the triangle. And then you translate the other points the same distance. So this isn't on a coordinate geometry diagram. So look, that formula's not going to work. A half base by height is basically for use with right angle triangles. Okay, so times height, whatever. So that's not really going to work. The other formula that might come up is a half A times B times sine C. So I have a strategy. Okay, I have an area formula. This one looks like it's going to work. And you could even write down all three and kind of exclude them. So I'm going to go with this. Now, do I have an angle? Okay, so do I have C? And you see here, do I have the two sides either side of it? Okay, so I'm going to call that angle C, which means this across here would be side C. Now, it doesn't matter what I call them, but if I call that angle A, well, then this would be side A. And the last angle left, I'm going to call it angle B. This would be side B. So, do I have an angle and the two sides either side of it? I do. Do I have A? I do. Do I have B? I do. Do I have C? So in this formula, there's four unknowns. I have three of the four, so there is only one unknown. Therefore, this formula will work. It's only a matter now of me going ahead and doing it. Okay. So the trick, in my opinion, with trigonometry is deciding on an effective problem-solving strategy, and then follow it through, doing the correct algebra. If you've chosen the correct strategy and your algebra is sound, you're going to do really well. Okay, so let's finish it off here. Okay, so I'm looking for the area. It's a half times, now I said A was 8. I'm going to use brackets to be multiplied so it'll program the calculator correctly. I said that B was 12. Okay, so identify it here. And that's times sine 30. Now sine 30 is the same as a half, but I can program that in the calculator. And I should have my calculator open, but I don't. So I have a digital version of a calculator that's going to be useful here. I hope it's visible. And if I put in there, so a half, and I can put in the fraction, a half, brackets for multiply, 8, second brackets, put 12 in, and then sine 30. It's going to close those brackets on that. So that's basically what I have on the page. Okay, if I press equal, go straight to my answer. Okay, so area is equal to 24. Now I am giving units. So the units here are centimeters, and they're squared. Okay, they're most likely on this is a mark for having the correct units. Okay, and that's it. Now it's really important that I show this step and then the answer. So if I have everything correctly into the correct formula, I'm going to do really well in terms of marks. If at that stage I mess up, I'll lose some, but I won't lose very many. Okay, if I had done this, I suppose, without having the formula, so let's say I just didn't have this here, okay, and I came along and I had the answer and I accidentally pressed them on the calculator and I got 22. It's kind of right, okay, I probably had the right strategy without anything here, again, assuming none of this is here, okay. All I see is an examiner or a marker, grader, wrong answer, no work shown, and literally you're getting 0. Okay, even though you may have had a perfectly good strategy, So there's room there to write down steps, okay, write down the workings, and I would encourage you strongly to do that, okay. And then again, for the name of the game here is achieving better and better marks. Now that's part A. Okay, in the notes there's the answer, just done out more clearly, hopefully. Okay, and that's part A. Now part B here it says a triangle has sides of length 3, 6, and 5 centimeters. Okay, find the size of the largest angle in the triangle. Now, one feature about triangles is that there's a relationship between the length of the side and the size of the angle. So the reason in a right angle triangle that the hypotenuse is the longest side is that it's across from the biggest angle, which in a right angle triangle is 90 degrees. Okay. This may not be a 90-degree triangle, I'm not sure. Okay. But the first thing I do is I try to draw it. Now you could do a scale drawing here, okay, or just even what we often call a pilot diagram. Okay, so I'm going to call that side 3, maybe side 5, so slightly longer, and then 7. Okay, now I'm not very good at drawing. Now it's saying find the size of the largest angle in this triangle. Now, knowing about triangles, that the angles have a direct relationship, this has to be the largest because it's across from the longest side. So that's the angle I'm looking for. Now, we have to assume it's not right angled. Now, we can test if it's right angled, okay, by running this through for effectively Pythagoras' theorem. This thing will work for me. So Pythagoras' theorem says the hypotenuse squared is equal to the sum of the squares of the other two sides. Now, I'm a bit old school. I use H. I know in the math tables they say C squared, so it's the same thing. The longest side squared equals the sum of the squares of the other two sides. So if this is right angled, well then 7 squared should equal, now I can say 3 squared, it's supposed to be a 3, plus 5 squared. Get rid of that, it doesn't look like a 3, and a square. Now, 7 squared means 7 by 7, which is 49. So is 49 equal to, 3 squared is 3 by 3, which is 9. 5 squared is 5 by 5, which is 25. And they are added together. So is 49 equal to 9 plus 25, which is 34? So it's not. So therefore, this is not right angled. So as soon as I realize that, okay, I realize I can't use the sine cos tan ratios, often called the trig ratios, and I can't use Pythagoras. Okay, so I'm just getting rid of them all here. This is just my problem solving method. So I'm left with either the sine rule, okay, for non-right angle triangles, or the cosine rule. Now the sine rule would be the one here, A over sine A equals B over sine B. If you notice in this, there are two angles. Do I have any angles in this question? Like I'm looking for one, but I don't have any other angles. So the sine rule is not going to work. So I can exclude that. Let's get rid of it, just to not clutter out the whole thing. So I'm going to be left with the cosine rule. Now, let me just ray out the whole thing. Minus 2 times b times c times cos a. And hopefully this is better visible. I know the background there is a bit darker than I like it. Now I can put all the numbers in and then rearrange them, but it's worth taking a second just to focus on the algebra here. In my experience in third level, or just with maths, we should always rearrange our equation to find the unknown before we plug in the values. Okay, and I'm going to do that now, even though in the next page in the notes, I have it done the probably more traditional way, or the way I would maybe personally have approached it when I was younger. So I have all three sides of this triangle, and I'm looking for this angle A. So I know what little a is. I know what little b is. I know what little c is. I've identified them here on the thing. The angle I'm looking for is the angle A. Okay, it's crossing the side 7. That's identified by little a. Now, the b and the c don't matter. I could have swapped them around and called the side of length 3b and the side of length 5c. It won't matter. What I'm going to do first here is I'm going to rearrange this for the angle A. So I'm going to bring literally everything to the far side. Now, the first two of the low-hanging fruit here is the b squared, okay, and the c squared. Now, how would I get rid of them from the right side? The simplest way is to take them away. Okay, so take away b squared, take away c squared. Now, if I do that, okay, I have to do it to both sides. So on the left-hand side, it's a squared, take away b squared, take away c squared, is equal to. Now, on the right-hand side, if I've taken like 2, take away 2 is nothing left. B squared, take away b squared, they're gone. So they don't appear in the next line because they're gone on the right-hand side. Now, the c squared, same thing. C squared, take away c squared is gone. So they don't appear in the next line. Now, everything else still does. They don't disappear. But if you see it, okay, I've made the right-hand side simpler. Now, the next trick is to realize that, okay, on the right-hand side, this is minus 2 times b times c times cos a. Now, one way to get rid of something that's being multiplied like that is to divide it by itself. Now, if I do it to one side, I have to do it to both sides. What's going to happen? If I have an example of 4 divided by 4 is always going to give 1 as an answer. When you divide something by itself, it always cancels and leaves 1 behind, or just cancels out. So here, they've cancelled. Now, on the left-hand side, they haven't. So you're left with a squared minus b squared minus c squared, all divided by minus 2 times b times c, equals to cos a. Now, I'm using a pen thing here, but I can move this cos across. This is the last thing. If I do that, I'm left with a, which is what I wanted, which is what is my unknown. So if I bring cos or sine or tan, but in this case cos across the equal, it turns into its opposite, which is the inverse cos. Now let's do it here, okay? If I do it, it jumps over the far side and becomes inverse cos of everything on the far side. Okay, so I have a new equation. It's a rearranged equation, but it's new in a sense. And that gives me the angle A, which is what in this situation is unknown. Normally, with this kind of question, it's the A I'm looking for. Okay, I have all the other 3 things. Okay, I just plug them in, put it through the calculator, and just be careful of the square, this thing here. Job done. For me now, okay, I can finish this off by just plugging in the values. If you notice here, the A, okay, was 7. I'm going to put that in brackets. Okay, the B, which appears on top and below here, was 5. I identified it as 5. I'll put it in both places. The last thing there is the C, and that was identified as 3. Now, if you see, on the left-hand side here, there's no unknowns. Now, I'm going to bring my calculator across again. I'm going to try program it. So it's inverse cos. Now, the cos button is here on my calculator, but the inverse cos is just behind it in the second function. If I press shift, cos, up comes on my screen the inverse cos function. Now, this is I suppose, a fraction. Click the fraction button. On top here, I'm going to use the brackets, so it's 7 squared, take away 5 squared, take away 3 squared, which takes time to program it. And then the bottom, okay, it's negative 2 times 5 times 3. Just going to make sure I go to the end of here and close off the bracket opened. I want to make sure it's closed off. Now, this should work. Okay, it did. I got an answer of 120. So what's the angle here? Okay, the angle is equal to 120, and the unit here is degrees. Okay, and that's it. Now in the notes, okay, I've done it slightly differently, I think. Okay, so same problem solving technique, only here I've used the formula as standard. Now the second line here, I've identified the 3 sides, A, B, and C. Okay, then I plugged the numbers in. So 7 instead of A, 5 instead of B, 3 instead of C, and the B and C appear twice. Then I'm going to rearrange everything. Okay, so I go 7 squared is 49, that's where that comes from. 5 squared is 25, that's where that comes from. 3 squared is 9, that's where that comes from. And minus 2 times 5 times 3 is minus 30. That's where that comes from. And then I start to bring them across the equal. Okay, this 25 was added on the right, becomes subtracted on the left. This 9 was added on the right, becomes subtracted on the left. Okay, and I just my next line here, I do that. 49, take away 25, take away 9 is 15. Then I'm just bringing the 30 across. The minus 30 is multiplied by the cos A. So when it comes across, it becomes divided. Notice the sign doesn't change. Okay. I did it a bit differently in the last page, but there's different ways of approaching this. I call it the fast way and the logical, mathematical way, the real way. Anyway, 15 divided by minus 30 is the same as negative half. Then bring the cos across and get inverse cos of everything on the far side. Inverse cos of negative half. Calculator will tell you it's 120 degrees. So I got the answer that way as well. And there's no right or wrong. There is a lot of potential calculation errors that can happen here. A lot of times people make, I suppose, just make mistakes. It's the more calculations you do, the more chance you have of making a mistake. We all do. But if you can identify the right formula, put some numbers in, you're going to do pretty well. Okay, and it's always worth keeping that in mind in a maths question. You can't get all of them right. I think most people would, given the situation of a pressurized exam. But okay, even on the questions that you think you aren't very good at or not skilled at, then if you can grasp a few marks here, grasp a few marks there, you're going to bring yourself up on the overall. Okay, so I think that's the end of question 2. Okay, so don't forget to like and subscribe to get access to more videos. And if you want the set of notes I'm working off, please send me an email at shanetroy@gmail.com. And best of luck.